Welcome to the DIY Honda Garage channel. This presentation focuses on DTC P2720, which stands for Pressure Control Solenoid D Control Circuit Low, specifically for the Honda HR-V models from 2016 to 2022. This fault code reflects an issue within the electrical circuit corresponding to the Pressure Control Solenoid D of the Continuously Variable Transmission CVT. Important to note, the error pertains solely to the electrical circuits and does not indicate any mechanical failures within the transmission itself. Understanding this distinction is crucial for effective troubleshooting. The location of the solenoid is typically within the valve body assembly of the CVT, a key component in managing transmission fluid pressure and fluid flow, thus impacting vehicle performance. The subsequent troubleshooting steps will guide through identifying and resolving the issue associated with this DTC. DTC P2720 primarily indicates an issue with the electrical circuit related to the Pressure Control Solenoid D in the CVT system. The role of this solenoid is critical as it regulates the hydraulic pressure necessary for smooth transmission operation. This solenoid is located within the valve body assembly of the CVT, and it works in tandem with various other components to maintain optimal fluid pressure. An effective solenoid function ensures accurate gear shifting and vehicle performance. Since the code specifies a low control circuit condition, potential circuit faults or breaks may prevent the solenoid from receiving the correct electrical signals. Understanding its precise location aids in addressing these electrical concerns during troubleshooting. Several possible causes can trigger the DTC P2720, the most prominent being issues within the electrical circuit. This could range from a damaged wire, connectors, or connectors that have become loose over time. Additionally, a blown fuse may disrupt the circuit and lead to the low voltage signal associated with this DTC. Specifically, a number C35 fuse, typically rated at 7.5A, could be the culprit if it is blown. Repairing an open circuit, which may exist between the pressure control solenoid and the powertrain control module, is also a key consideration. It's important to diagnose these issues correctly as they all involve electrical components rather than mechanical failures within the transmission itself. As with many diagnostic trouble codes, symptoms related to DTC P2720 often manifest through various vehicle performance issues. A primary symptom includes erratic or poor transmission performance, which may be easily noticeable during driving. Drivers may encounter irregular shifting or slipping gears that can lead to dissatisfaction with the vehicle's handling. Furthermore, the check engine light is likely to illuminate, signaling an issue that should be addressed. In some instances, drivers may experience a loss of power or acceleration, particularly when trying to merge or climb inclines. These symptoms warrant a thorough investigation of the electrical systems surrounding the solenoid. The first troubleshooting step involves verifying the problem through the Auto Diagnostics system, HDS. Begin by turning the vehicle to the on mode without starting the engine. It's important to ensure that potential electronic systems are active for accurate reading. Next, clear the existing diagnostic trouble codes using the HDS tool. This step resets the DTC status. After clearing the codes, start the engine and wait for at least 1 second. Finally, check again for any pending or confirmed DTCs using the HDS. If DTC P2720 appears again, this confirms a repeated issue and the troubleshooting can proceed to the next step. If not, consider the possibility of an intermittent issue and inspect the connectors and terminals for any signs of wear or looseness. In the second troubleshooting step, begin by turning the vehicle off to ensure no current is flowing through the circuits. Following this, utilize the HDS to jump the SCS line, which allows for testing without interference from other circuits. Disconnect the PCM connector A, which has 51 pins, specifically from the vehicle to avoid any additional variables. After these preparations, turn the vehicle to on mode again. Now you need to measure the resistance between the specified test points. Test point 1 at PCM connector A, pin 1, and test point 2 at body ground. If the resistance indicates battery voltage, this suggests the IG1 missole wire is intact, allowing you to proceed to the next step. If not, investigate and address potential issues with the number C35 fuse or any open circuits in the wire between the powertrain control module and the under-dash fuse relay box. At this stage, the troubleshooting involves assessing the functionality of the CVT lockup clutch control solenoid valve. This component is crucial for the vehicle's transmission efficiency and response during various driving conditions. Conduct the appropriate tests to determine whether the solenoid functions optimally. If the solenoid performs as expected, you can proceed to the next troubleshooting step. However, if it does not work properly, you will need to move to step 5 to explore further causes. This step focuses on confirming the health of the solenoid, as its failure could directly relate to the DTC present. The fourth step in the troubleshooting process requires disconnecting several components to isolate the issue. Start by ensuring the vehicle is turned off, and again, jump the SCS line via the HDS. Then disconnect the PCM connector B with its corresponding 51 pins, as well as the solenoid wire harness 8P connector from the engine harness side. This will provide a clean slate for checking continuity between test point 1, solenoid wire harness 8P number 8, and test point 2, PCM connector B number 4. If continuity is confirmed, it suggests the LCCLS wire is functional. In this case, consider whether the powertrain control module has the latest software version. If not, update it, or alternatively, substitute a known good PCM and retest. If DTC P2720 resolves following these updates or substitutions, the issue is complete. If not, further investigation into the wire connections may be necessary. In the final troubleshooting step, focus shifts to assessing the CVT lockup clutch control solenoid valve's integrity. Begin by removing the valve body assembly from the vehicle, ensuring that all components are handled with care to prevent unnecessary damage. Once removed, disconnect the 2-pin connector from the solenoid valve. Then, measure the resistance between the specified points in accordance with the guidelines. Ideal resistance should fall within the range of 4.6 to 6.3 ohms. If this measurement is achieved, the solenoid itself is functional, and attention should turn to replacing the solenoid wire harness. However, if the resistance falls outside this range, it indicates a faulty CVT lockup clutch control solenoid valve, which necessitates a replacement of the valve body assembly. Thorough identification of the faulty component is critical in restoring optimal performance. After completing all necessary repairs related to DTC P2720, it is essential to conduct a final verification to ensure that the vehicle operates correctly. Utilize the Auto Diagnostics System, HDS, to recheck for any existing DTCs. This step is pivotal in confirming that the previous issues have been rectified and there are no lingering concerns within the system. A successful repair will show no return of DTC P2720 or other related codes. It's also beneficial to take the vehicle for a test drive under various conditions to observe its performance. If all runs smoothly, this indicates the repairs were successful and thorough, ensuring long-term reliability. To prevent future occurrences of DTC P2720, proactive maintenance is key. Regular inspections of the electrical systems, particularly around the solenoid and powertrain control module wiring, help catch early signs of wear or damage. It is important to monitor the condition of the connectors for signs of corrosion, loose terminals, or fraying wires. Scheduling routine checks can identify potential issues before they escalate into significant problems that could impede vehicle performance. Additionally, ensuring that the components have updated software can prevent glitches that may misrepresent the system's health. By following preventative measures, drivers can maintain their Honda HR-V in top condition and mitigate costly repairs. In summary, DTC P2720 presents an electrical issue within the Pressure Control Solenoid D circuit rather than a mechanical failure. Understanding this distinction is crucial for effective troubleshooting and repairs. The outlined steps provide a comprehensive pathway for locating and resolving the fault. Each step emphasizes the importance of verifying electrical connections and ensuring the solenoid functions properly. By adhering to suitable preventive maintenance practices, vehicle owners can prolong the life of their Honda HR-V and minimize the potential for similar future issues. Ultimately, through vigilant monitoring and timely repairs, drivers can ensure their vehicle operates smoothly and reliably. Please like and subscribe to the channel. See you next time.